Hello, nice to see you again. I'm Chris. In this tutorial, I'm using a little bit special Mitsubishi module in their IQ-R series. It's called RJ71PN92. It's a Profinet master module. It will say it's Profinet IO controller modules. By using this module, you can configure a Profinet network in the IQ-R series PLC, and then to configure a Profinet master or IO controller, and then connect to different devices. In this tutorial, we will use a TwinCAT TF6270 to configure a Profinet device, and also I will use a IP67 Merge protocol IO control IO block from Belden to configure a Profinet network, and I'll show you how to do it step by step. Before we jump into the tutorial, I need to introduce a little bit more to you about the modules. If you want to use the RJ71PN92, you need to connect to your local Mitsubishi office to get a GX converter PN set of files from them, because if you don't have these files, you cannot configure your Profinet network. So here is some specifications that I screenshot from the menu. Then you can also check the whole specification from the menu, and here I'll just pick up some main highlight points in here. For the Profinet network, for this module, the maximum data size is 4096 words, and same as output. And for each IO device, you can exchange maximum 1037 bytes. Okay, and for the cycle time, from minimum 1 millisecond to maximum 512 seconds, so milliseconds, that you can configure it as you like. And for the maximum numbers of connecting device is 128. So you can configure it is very big networks. So here is also a screenshot I got from the menu. If you want to use RJ71PN92, then you need to be careful that not all the PLC module, not the PLC can use these modules. And here you can see you get RN, RN, RNP only can use this module, And so please be careful that if you want to use this RJ71PN92, then you need to choose a correct PLC. And also that there's some software limit, and here you need to make sure that your GXWorks free version is at least 1.032J, and for the GX converter PN is at version 2.008. And for GXWorks, you can just go to the homepage to download the update files, so it's not a very big deal. So here is the basic configuration. So when you want to not just use this module for the Profinet, if you want to configure a Profinet network in a Siemens or in Beckhoff or any controllers, here is the modules, and this module will be an IO controller. It will be master. Then this master will be connected to a device. It's our IO device. Profinet IO device is okay. Also called its slave, but the formal naming is called IO device. Then here is connecting in Profinet, so only IO data. The IO data will exchange from with Profinet. Here is a real-time communications, and then you have a workstation in here, and this is called a supervisor. Then you can download your program, you can download your hardware configurations, you can assign the device name, all the stuff you can do by this way. So here will be GXWorks in here, and then this is just a rougher flow to show you how to work with RJ71PN92. But first one, actually you need to install the GX converter PN, and then you need to configure the RJ71PN92, and then to set the IP address, and then to latch the software, and to import the GSDML file. GSDML file, I think I mentioned it so many times before, it is a file that just like EDS file in Ethernet IP or ESI file in EtherCAT, but different to Ethernet IP. Ethernet IP, even you don't have a EDS file, you can still use generic EDS file to configure your network. But for Profinet, it's not possible. You must get the GSDML file from the manufacturer's homepage or directly get from the manufacturer. After you input the GXML file, then you can configure your Profinet device. Then you can update your global labels. Here is the GXWorks side. Then you can download the configurations, reset the power, and assign the device name. For Profinet device name is very important that I just say need a bit of each power cycle turn on. The IO controller actually will send DCP protocol to all the device that, for example, do you have this name? Yes. And then okay, I send out names as etc. like this. And you need to assign the name. So if you don't give the name to the Profinet device, IO device, then the IO controller do not know that which device is for what. Okay, and then after you assign the device name, then you start the Profinet real-time communications. It looked like a little bit complicated, but actually it's very easy. Then don't worry, I will guide you step by step to do this. Okay, now it's the time for live demo. And before I start the live demo, I will turn on my camera, and then I'll show you the real hardware configuration, and then to explain what the real hardware I'm using here. Okay, here is the camera that I turn on, and you see the whole configuration I'm using here. And for this one, here's the Mitsubishi IQ-R series CPU. It is the power supply. This is the rack, and here is the CPU that I'm using this time. It's a R04EN CPU, and here is the Profinet module. It's RJ71PN92 something. I hope I remember it properly. And here is the I/O from Belden. This is a Beckhoff C6920 IPC, and here we will configure as a Profinet I/O device. And here is the Profinet I/O controller. This one is also Profinet I/O device. And here is just connecting to e-stop. Here the e-stop input, and here is the e-stop output. Then now I just want to configure that if this both signal want to turn on, I'm just turn on the light in here. It's a CMOS applications. And for this side, I will I'll generate some random number, and then I will send to the Mitsubishi CPU, and then we will open the watch table to check all the data is correct or not. Very easy. Okay, let's start. Okay, now we open the TwinCAT project. We can start to configure our Profinet I/O device in here. The first thing, I need to add a Profinet device, but before we do this, we need to configure our connections from our PC to the IPC C6920. Because now I'm using my own PC, then to directly download and take the configurations from the IPC. So I need to configure the connections first. Go to System and choose Target, and go to here and just choose what the target that you're using. In here I'll use this CP-1-IC8674. Just press OK. Great. And then we can add the Profinet device now. Go to I/O device, right click, add new items, and then choose Profinet I/O device in here. And then after that, the first thing you need to do is to go to adapter, and then to search to choose which adapter that you would like to use as a Profinet device. In here I'll use this Ethernet, this first one. Okay, and then we can go to the synchronized task. We can create a own task for our Profinet I/O device. Then choose this special synchronized task and click the create new I/O task and enter your task name, and then configure your cycle clicks for your Profinet I/O device. It's very important that, for example, now I'm saying 1 millisecond is the minimum of cycle click in here, but for example, if you first set the cycle click as 64 milliseconds, okay, and if your I/O controller to try to get your data in every every 32 milliseconds, then you will fail because your TwinCAT controller, TwinCAT Profinet out controller, out device is not cannot handling the cycle time like this because you config the cycle click is 64 milliseconds. So this you need to make sure, and you need to make sure that the cycle click and the cycle click is in the Profinet device is smaller than the Profinet controller would like to take your data. But anyway, just say 1 millisecond here, it should work. After that, we can add the device in here. Just right-click Profinet our device, add items, and then choose BNTC device. And here's a couple versions in here. I think at Profinet PI they will update the Profinet version. I think per 1 year or 2 years something. So the version will change, and I'm sorry that I cannot get the informations. If I cannot search the informations in the Mitsubishi manual that to know what kind of which version at least they can support. So, but in this way, I will config my Profinet IO device in my TwinCAT as 2.0 and old version, and then in the Belden is using new version. I think it's 2.32 something. Okay, let's choose TwinCAT device 2.0 plus OK, and then here our Profinet device is created in here. Then we can open here an API. Now only have one terminal 1 DAP module. Then we need to add our own slot. So how to do it? You can just click on the API, right click, add new items. Then the device configuration window is showing here. Then you can configure all your data that you would like to do. In this case, for the first slot, I would like to configure a 64 works. So I go to work modules, and here's a 64 works input and output. I just double click it, and the slot 1 will be 64 works input and output. And then for the second one, I would like to configure a phone number. So let's go to phone 32, and then throw 10 phone numbers in output. Double click it, finish. And finally, I would like to define a 100 double work in here. Let's click the dwork modules and go to 100 dwork in and out. Click here and then finish. No need to do so much things. Okay, great. Now you configure your Profinet device. The next thing we need to do, we need to add a PLC project. Go to PLC, right click, add new items, PLC template, and standard PLC project, and add it into your TwinCAT project. The first thing I would like to create a DUT, a structure type. I would like to data DUT data exchange with music, and here it is. Okay, then I will define some data in here. The first one is data works. You say array, ARRAY, 0 to 63 of work, and data flow is array 0 to 9 of flow what view, no, false view, and the data the work is arrayed with 99 with 100 of elements. It is a D work. Okay, it's just like this. Finish, and then we can add a GB values in here, and then call it data, and then just need to put in, and then I can data from millisec. Okay, millisec is at %I star mark, and then DUT data with millisec, exchange to millisec, and data to millisec same as %Q star mark DUT data exchange with Millisig. Great. And then finally create our own program here. I will create a integer first for me to take care of my loop, input loop, and then I will create a function block. It is for me to generate the random number, and then I will like to define a variables to let me to receive this random number. The first one I will call my functions, and then I will get the result of my function block. I think it's numbers. Then I get a seed for him for this one, for example 5.0. And I for I equal to 0, 0 to 99 by 1 do, oops, by 1 do, and then GVL data doc data to Millisig doc data dworks I is equal to what? Real to dwork, okay, and then 100.0 multiply the random number and then multiply I plus 1. Just very simple, right? And then just do this for other one. I is equal to 0 to 9 by 1 do, okay. GBL data dot data to Millisig dot data flow I is equal to what? Equal to 10.0 multiply random number and multiply I plus 1. Great. And then finally for I equal to for I equal to 0 to 64 by 1 and do by 1 do, and GVL data doc data to Millisig and doc data works, okay, and I is equal to I plus 1. Great. Okay, it should work. Then after we create the project, we can create the program. We can build our solution to make sure I didn't have any error in here, and then I can start to map my data. They go to API terminal 2, and that's the input, and just click here, and then select all, multiple change link. Great. And for the output, do the same thing, multiple change link, and map it. One time if you map your data, then here you show X icon here. That means this variables process input output is map some data into your user program. And just do it for here, and just the same thing, map it, and go to output, map it, okay, and then for the input, just do the same thing, map it, for the output, do the same thing, and then map it, okay, and then we can try to build our solution again. It should work, and then we can download our hardware configurations. Okay, and then we can log in and then play our system. Now you see it should data is running, it should work. Now for the TwinCAT side is finished, we can shift. Oh, there's a thing I forgot. You need to generate the GSDML file. Go to your Profinet device and go to the GSDML generator, and there's a button called create GSDML from original. Click it and just import your GSDML to somewhere, and then after that we'll go to import this file in the GXWorks it means in the Mitsubishi side. Okay, now in this side finish, we can start to do the Mitsubishi side. Let's go. Now we can start to configure the GXWorks free side also, and I already create my GXWorks free project. The first thing I need to do is I need to configure our module configurations. So go to project, module configurations, open it, and now here you can just have your PLC. Then you can add a rack inside R55B. I think it's Y here, right? R55B. Yes, sure. Add a power rack in here, and then drop our CPU inside. And then the second, we need to add our power module is R61P. Drop in here, and then in the slot 0, we need to add a CPU extensions. Why? Because for the Mitsubishi CPU R04E, they have using 2 slots. The first slot is for CPU, and the second slot is for extensions. And the extension, you can use this extension slot for Ethernet, Ethernet or CC-Link, IFU or something. It depends on application, but you need to add it. If you don't add this extension slot in your project, you face error. So go to CPU extension. There's 4 types allow you to choose, and now you just use this one. I think this one is Ethernet, CC-Link, IFU plus Ethernet something. Okay, just drop in here. Great. And then finally, we need to add our Profinet I/O modules, Profinet I/O controller modules, RJ71PN92, and just drop to here. Great. And then we can save our project. Be free. Yes. Okay. Yes. Okay. Great. And the first thing, we need to check our parameters. Go to tubes and check parameters, and there's no error, so it means your project without any problems. And in here, our main target is to need to configure our Profinet network. So the first thing, we need to open the RJ71PN92. For the module parameters, you need to configure the IP address. Then in my case, I'll use 192.168.5.19.159, and for the subnet is 255.255.255.0. And check it. If any error, no, and okay, and then check again. Great, and save it. So now the parameters should be 5.195. Great, no error. Okay, now and then we can start to configure our Profinet network. We need to open the Profinet module setting tabs. Then you start in other tubes in here. So by default in here, you only have your Profinet I/O controller, and here is your device library. Then first thing, you need to import your HTML file. But because I test the module before, so the DST file inside here already installed. You need to just plus the add file, and then plus next, and then choose the GST file that you export from TwinCAT or you download from the Belden home website, and then plus next. Then you directly import the GST file to your device library if there is not any error. Okay, then we can start to configure our Profinet network. First thing, I would like to drop the TwinCAT device V210. Just drop it here, and then here's device name. You need to take care. Then we need to assign in later. And then here, that is the IP address. How to set up this IP address? Then you can just change the IP address, the number of your device. I slow it to 99. Where's 99? Great. And then see the IP address will directly change to 99. And for the module configurations, you don't need to set anything because we directly set the this slot is for what, this slot is for what. For example, for the Siemens device, maybe the slot you can free configurable set up to you. The first slot is for some data input, some flow data input. The next one is for some boot data input. But this way we configure all the data fixed, so we no need to check. We no need to configure the slot by slot anymore. And go to parameters. I would like to change the cycle time to 1 millisecond. Great, and just press OK. Great, you're done. And the next thing, I would like to create the Belden IO in here. I think the IO is using is 353932121, right? 39121. And then just enter the device name, and then set the device number. I choose 111 here. Okay, and then you don't need to set anything here. Go parameters. I'll change it to 1 millisecond and press OK. Just save it. Finish. All you need to done in Profinet in the GX configurator PN is only this. Let's save it and then close it. And now you can start to configure your project again. So right click this module, and this couple things you need to set up. The first thing, you need to set up the auto refresh setting. So this setting is you need to assign which device that you will get the data from the Profinet IO controller module, and then they will transfer to your register. You can use W, M, D, or anything that you want. I'll use W0. And then press OK, and it's let you map again. Great, and save it. And then the next one you need to do is you need to refresh the Profinet labels. Here's a button called Update Profinet labels. Okay, great. Now you see it's done. And okay, now you see there's some data types created here. I open this tubes again to show you why the computer is set like this. And here, for example, you see this is V099 something, because my TwinCAT Profinet IO device is set as device number 99. Same theory, because my Belden IO block is set device number is 111. So here will be 111. Very simple. Great. If you're afraid that, just update again. Make sure there's no any error. Update. Great. Close it. Then now we can start to create our program. I will open the local label first, and then first of all in here I will create variables called PBN connect. OK, TwinCAT3. Just to make sure now the data connecting the TwinCAT is okay without any problem. Then we can zoom here. We can start the programming. The first one is GL RJ71PN92 _3. So what is this one? As well is the variable in here. It will automatically generate in your system, so no need to take care of it so much. This module will be related to this Profinet IO controller. So .what STMGMT output doc B regis doc B regis B this one, yeah, required data exchange start request. So when you turn on this speed, the Profinet IO controller will start to communicate with all the Profinet IO device. Is equal to what? GL R1 RJ71PN92 _3 doc STMGMT.input doc B status _configuration status 99. 99 is, I told you before, is the device number of my TwinCAT Profinet IO device, right? So is this bit changed to 2? It means that how to say, Right, wait, I think that I make some error in here. This should not be this one, sorry. Not this one, it should be RG equal to GL RJ71PN92 underscore 3 dot st mgmt inputs, sorry, dot b status, sorry, boss status. So it means the module is configured, is ready to use. Then the speed will be turned to true. Then I can start to send the request. So this one is for B, PN connect TwinCAT equal to true is equal. Okay, TwinCAT is equal to speed. It means that the connection between TwinCAT Profinet out device to the Mitsubishi out controller is done. No problem. Okay, after that we can start the programming. First of all, I would like to G L R J doc SD SLV doc SLV right, SLV 099 SLOT 00 data 001 data out doc output is equal to GLRJ doc SLV 099 SLOT 001 data structure in doc slot 001 well in. It means the first input, when I get it, I will feedback it to the output. So in triggers, I also receive the same output, right? Same input. And then just copy it. Oops, I just copy this one. And then I can just paste it to 62, the last one. Great. And yeah, I can do it to the same as for other register. GLRJ dot SL3 SLV 099 SLOT 002 dot structure out dot flow is equal to GLRJ dot SLV 099 in 2 is not 1, it's 2, come on, 2 in dot flow. Okay, we can just do it to copy paste, and I think it's the 8, the last one, and then do it to the same thing to last slot 00 slot to 003 data structure out dot SLT 002 003 and 1, and D1 output is equal to what? Is equal to same RJ GLRJ71 dot SLV 099 SL03 data in dot SL3 dot D1 input. Okay, and just copy it and go to the last one. Great. And then we can try to program our Belden IO. How to do this? GLRJ slot dot SLV 111 slot dot output doc 0, so it's the first output, is equal to what? Equal to first one is GLRJ1 dot SLV 111 SL001 in dot 0 and GLRJ1 dot same things 111 slot dot in dot SLT 001 dot 1 and I would like to give it 1 millisecond pulse. So I would like to add the module labels. Yeah, from here I can add all the CPU labels. Great, but actually I don't use all. I just use a 1 millisecond pulse. Our CPU doc st sm 1 b dot b 1 clock. Great. So here is the first output will be turned on, while my first 2 channel input have a true signal. Then we can compile a project to make sure no error. Great. Why? Is equal to what? B not array. Not array. Yeah, sorry. Doc B. I see. I make something wrong here. Doc st doc st doc st I think I make some error here. mdi inputs, right? Doc b and status, connection status, and 99. Sorry, yeah, should be this one. And then I can compile my project again. Compile all to make sure no error. Then I save it. I can download it. Then make sure don't check this box. If you don't check this box, the configurations of Profinet controller will not inside your project will not download the controller. It will be very tricky point. Execute it. Yes. Then turn on the run mode again. Okay, now I will reset my power of my CPU. Just wait a second. Great. Now my CPU is. I reset my CPU. Then we can go to online first. How to go to online here, right? See, this will be true. It means there's no error. The data is connecting, and then we can open the configuration tubes. Oh, sorry. I need to show you how to assign the device name. Just sorry. And go to Profinet setting again, and then go to the network detections, and plus the and plus this one, online actions. Then you try to scan all the device in your network, and then one time then if you want to assign new name to this device, you click it and enter your name and plus assign name, apply name. Then if you don't check this box, then after the power reset, the device Profinet our device will return back. If you check this one, then we will save it. The Profinet our device will save it, and you will the device will not forget what you config on this. For example, the device name, IP address, something. And here I already assigned all the device. So then we can go to the online. Then you see both of this one is in green conditions, so it means it's connecting without any error. Then we click this, go to IO data. You can see the IO data is exchanging, right? It's also in OK. And then we can go back to GXWorks in here. And yes, we can go to online, and then we can just check some variables here also. For example, for the first one of output, we can just right click it and register to watch table, and to the input watch table. You see the output is same as input, and then you can also register a flow number. Oops. You see this value also same, and we also register the D works is the double work. You see they were the same in here, and finally now you see the output is flashing because now my UGC stop is released. Then we open my camera. So here is our camera. Then just a second, I'll try to press this button. And you see now that the bottom the lamp output or the button will turn off if I press the e-stop. It means because I write program here, so the program is work also. Okay, I think in this video is enough. I hope you like this, and I hope you see you in next video. If any problems, please feel free to comment and please like my video if you liked it. Because I'm sorry that my English is not very good, and I hope I can see you in next time. So have a good day. Bye bye.